All right, so here's the second part to chapter 2, section 2. So we're going to call this section 2b, and this is the domain. So we started this already. We talked about that the domain is the x values. From the graph, it goes left to right. We established that domain is all real numbers except for if there's a variable in the denominator, if there's a variable under the square root, or the combination of the two if there's a variable under the square root and the denominator. If it's just in the denominator, we set the denominator not equal to 0. If it's under the root, we set what's under the root greater than or equal to 0. And if it's a combination of the two, we set the expression under the root greater than 0. We worked through these examples and we left off here. So now with number 7, there's a variable in the denominator. So that cannot equal 0. And I get x cannot equal positive 5. So in interval notation, it would be negative infinity to 5, union 5 to positive infinity. In words, it's all real numbers except 5. Number 8 also has a fraction. So I look at the denominator. I set this not equal to 0. I'd get 2x cannot equal negative 1 and x cannot equal negative 1/2. In interval notation, that's negative infinity to negative 1/2, negative 1/2 to positive infinity, or all real numbers except negative 1/2. For 9, I've got a variable in the denominator, and this time the denominator can be factored. So I would factor out my denominator, x plus 1 and x minus 1, and neither of these can equal 0. So x cannot equal negative 1 and x cannot equal positive 1. So in interval notation, this is going to go from negative infinity to the smaller value, which is negative 1, with a parentheses on it, union the space between these two, which would be negative 1 to positive 1, union the bigger one to positive infinity. So when there are two not equals, that's how you write it. Negative infinity to the smaller, smaller to larger, and then larger to positive infinity. All real numbers except negative 1 and positive 1. All right, looking at 10. This time I have a variable in the denominator. I could set it not equal to 0. This can't be factored, and when I move the 4 to the other side and try to square root it, I am square rooting a negative number. And there are no real number solutions to this, which means this is actually no restriction, and my domain would be negative infinity to positive infinity or all real numbers. So if there's no value that I can make the denominator 0 with, then it's all real numbers. 11 is our first square root. So the square root, remember, whatever's underneath that square root can't be negative. So I set whatever's underneath it greater than or equal to 0. In this case, that's going to be x is greater than or equal to 0. In interval notation, that's 0 with a bracket on it to positive infinity. This is all real numbers greater than or equal to 0. For 12, I again have a square root. I'm going to set what's underneath it. So x minus 3 greater than or equal to 0. Add the 3. X is greater than or equal to 3. So in interval notation, it's 3 to positive infinity. And it's all real numbers greater than or equal to positive 3. All right, continuing on domain 13, another one with a variable underneath the square root. Set what's underneath it greater than or equal to 0. I would add the 1, divide by 2, and I get x is greater than or equal to 1/2. So 1/2 to positive infinity, or all real numbers greater than or equal to 1/2. (14), another square root. So 4 minus x is greater than or equal to 0. You can move the x to the other side. 4 is greater than or equal to 0, but you want the x to come first when you're saying this out loud. So x would be less than or equal to 4. So now it's negative infinity up to 4, including 4, or all real numbers less than or equal to positive 4. All right, now 15 and 16 are the combination of the two restrictions. There's a variable in the denominator underneath the square root. So I look at what's in the bottom, and it can no longer be greater than or equal to 0. It's just greater than 0. So this one has nothing to solve. It would be 0 with a parentheses to positive infinity, or all real numbers greater than, not greater than or equal to 0. For 16, now what's underneath the square root is in the denominator, but there's more than just the x. So 2x minus 1 would be greater than 0. Add the 1. 2x has to be greater than 1. Divide by 2. And x has to be greater than 1/2. So there's a parentheses on the 1/2 to positive infinity, or all real numbers greater than 1/2. And last set of domains get a little bit trickier because you've got something in the top and in the bottom. So if I look at 17, I have a restriction in my numerator. This has to be greater than or equal to 0. In the denominator, this has to be greater than 0. So with these, I would recommend solving them and then putting them on the number line to look at what you've got. So in the numerator, x minus 1 has to be greater than or equal to 0. X would be greater than or equal to 1. And x plus 2 has to be greater than 0, so x has to be greater than negative 2. Has to be true for both, so this is an and statement. So when I graph this, the first one says, I've got negative 2 and 1. The first one says greater than or equal to 1, so it would look like this. There would be a bracket on the 1 pointing towards the right. And the second one says greater than or equal to negative, or greater than, not greater than equal to, greater than negative 2. So it's a parentheses on the negative 2 pointing towards the right. Now, because it's an and statement, it's only true where both overlap, which is at positive 1 to positive infinity. So my interval notation here would be 1 to positive infinity, and my written word would be all real numbers greater than or equal to positive 1. Okay, another question similar to that is 18. So I set my numerator greater than or equal to 0. The denominator is just greater than 0. So 2x minus 1 is greater than or equal to 0, and x plus 3 has to be greater than 0. Add the 1. 2x is greater than or equal to 1. Divide by 2. X is greater than or equal to 1/2. Subtract the 3. X has to be greater than negative 3. Draw your number line. The first one is greater than or equal to 1/2. So it would get a bracket on the 1/2 pointing towards the right. The second one would be greater than negative 3, parentheses on the negative 3 pointing towards the right. And again, we're only looking for the overlap, which would be from positive 1/2 to positive infinity, or all real numbers greater than or equal to 1/2. And we save the best for last. So this time you've got your inequality in the top because this is greater than or equal to 0. In the bottom, you've got a greater than 0 situation, but it's quadratic. So the numerator is easy. We just find that x is greater than or equal to positive 1. But the denominator, we go back to our quadratics and our inequalities. I solve this as though it's a factoring question, and I get the 2 zeros. I would plot those on the number line. And I would try to figure out which of these ranges work. So if I pick the 0 and I plug it in here, 0 squared minus 81 is greater than 0. Negative 81 is not greater than 0. So I know I have to point my arrows out here. So the result of the denominator is the purple, negative infinity to negative 9 with a parentheses, and then positive 9 to positive infinity. The result of my numerator is that it's greater than or equal to 1. So 1 is in here. Greater than or equal to is a bracket pointing towards the right. Now again, it's only where these overlap. So this gets ruled out because there's only one part there. Before the 9 here gets ruled out because that's only for the one statement. The only time in which all three overlap would be from here to positive infinity. So I'd get positive 9 to positive infinity. Or all real numbers greater than, not greater than or equal to, positive 9. Now, when I say all three overlap, I mean the first statement, which it's going to be the or statement. It's this or that. But then this with that is an and statement. So I really only want where the orange and the purple overlap, which is where this is over here. And that's why it's 9 to positive infinity. All right, that's the end of 2-2b. So homework is due on Monday. Hopefully you have a little bit of time to work on it now so that you can have just a smaller assignment for the weekend. Have a fantastic homecoming weekend. Have a fantastic Halloween, and I will see you guys Monday morning.